I will be the main presenter for this presentation, but all of the content for this has been developed by all the presenters for the topic that we are going to be doing today. Um, so just to kind of have a brief overview, I think it would be nice that after this presentation, you should be able to apply basic programming concepts, understand the syntax and logic that Python uses, which is the language that we will be using, and take those and apply those so that you can create a program that can manipulate data, make decisions off that data, and make use out of those data tools so that you can create your own tools. And I should iterate that this presentation is going to be short compared to what would be considered like a longer Python class. So there is going to be a lot of like kind of quick explanations. If you have a question, feel free to ask me, and I'll try to do the best that I can to explain it. So a quick overview of what we will be looking at. We'll have some kind of programming and engineering. I know that not everyone here has an engineering background, but you might get a kind of an understanding of like where and why we are using this programming, why we're using Python, and kind of a brief introduction to it. And then the real in-depth portion of it where we have all the syntax, the commands that you'll be using, how to use Jupyter Notebook, and then ultimately we'll kind of dive into some examples that you guys will work with me. So first we'll look at programming and engineering. So how do we use programming, right? So probably some of the most famous examples are in aerospace and like NASA's applications, like for instance the Apollo flight computer. Some of us though, especially in the civil field or those that use ArcGIS, engineers that need to understand surveying, also need to understand programming so that you can apply those so that you can create these tools. Same thing with other stuff like Civil 3D, Autodesk Revit, AutoCAD, stuff like that. So but what about more specific things like what we're doing? So, like in the energy sector, you can use machine learning to accurately predict energy consumption based off of how people act inside of a building. Or maybe you can predict contaminants in a water supply and how that distributes over a water supply system. Just some very, brief examples to kind of get you thinking about it, right? So, how do we interface with computers? And this is kind of an important step to this so that we understand what we're doing in Python. So with computers back 30, 40 years ago, you would have a strict command line interface, meaning that you had to type in the commands that you wanted it to do. This meant maybe mathematical calculations, copying files. And you can see an example of that here on the right with what was considered the early DOS terminal. Uh, Advances in graphical interfaces, sometimes called graphical user interfaces or GUIs for short, allow these commands to be performed much easier without needing to know the syntax of these commands. So maybe you're pressing a button, dragging a slider and typing in numbers to do things. But all of the stuff that happens behind the scenes is still the same. So you can even see an example of this inside of Windows. Windows 10 Terminal, the command prompt, as some of you may know it, it still functions almost exactly the same as the MS-DOS terminal. And it's just a more advanced version that has been changed over the last 20 years. So we have these applications that we use on it. And these are things that come in the form of a variety of things. Skype, for instance, Microsoft Teams, what we're using right now. Video players, if you want to watch a movie, listen to Skype, or not Skype, music on like Spotify or Apple Music. Using Microsoft Excel, Microsoft Word, all sorts of these different programs are applications, and they are complex sets of scripts and instructions that are programmed together, right? So to answer that question, these are made with programming, right? So These are written in a programming language, and programming languages are just like any other spoken language. They have their own rules and grammar and spelling. This is the syntax of this language, and this is very important to learn when you are working with a programming language because this is how the computer interprets its instructions. So, and it's important to note from this, the key takeaway from this here is that when you give a list of instructions to a computer, it interprets it sequentially. Um, and I think here, actually, yeah, you posted the survey. Okay. I can give you all a few minutes actually to finish that survey out. Um, I think I just answered one of those questions for y'all. Whoops. I'll wait for everyone to finish their survey here, I think, and then I will continue. Just give y'all a couple more minutes on that. I apologize for that. Okay, so hopefully I'll hit enough time to get through the survey. So we'll kind of cover over some of those questions that were in it. All of that's covered in the content for this. So, okay, so yeah, the syntax of a language is all of the rules that are about it, all of the grammar and spelling and things that you need to do to make sure that Python understands what you want it to do correctly. And what's important to remember in this is that the computer looks at everything that you enter from the first thing to the last thing. Um, and we'll kind of cover this here a little bit later. So let's have an introduction to Python and the language that we'll be using. So you're probably wondering, why are we using Python? There's tons of languages out there. Some are derivatives of others. So you've probably heard of something like C++, maybe Java, JavaScript, C Sharp. There's lots of languages that exist out there. And some have different strengths in areas. An example of this is that C++ typically has better performance than a lot of other languages, given that you know how to use it. However, we will not be using that. We will be using Python for our selected language. So why are we using that, right? That's because Python is known as like a high level language, meaning that it's easy to navigate and use. It self manages its memory, so there's not anything that you would have to do in terms of like making sure that your computer doesn't crash. A lot of times, Python will do stuff behind the scenes that allows it to keep itself from crashing, basically. That's not to say that it's not possible. It's definitely possible to crash it. Another part of this being a high level language is Python requires considerably less work to do things. So an example here on the right is doing the same thing between Java and Python. Python takes one line, whereas Java, if you were using the correct syntax and rules and nomenclature, may take 4 to 5 lines. And this can greatly change depending on what language you're using. I give examples like C++ and assembly. Assembly takes a really long time to program something. And the nice thing with Python is it has a really large online community. So you can go onto websites like Stack Overflow or the Python Wiki or any of the libraries, and we'll talk about that in a minute. They all have wikis, communities, forums that people post on and ask questions. And most times, if you have a question about something, you can almost find someone that's asking that exact same question and you can get a nice answer for it. And really, it's arguably one of the more powerful languages that you can learn that has the easiest learning curve. And it's important to note, if you want to do research as a job, Python is very popular with researchers, companies, government work, universities. That's why we are teaching it, because it's very well known to be like used. So, brief history of Python. It's influenced by a ton of different languages. And the kind of philosophy behind this language is it focuses on code readability and the use of indentation. And like I mentioned earlier, it's very popular, right behind the other two foremost used languages as of 2021. Um, and what's important to note is there's a lot of behind the scenes work that Python does that you would normally have to do in another language. So an example of this is you can just set a variable to a number without having to say what type of variable it is. And I will go into a little bit more explanation on this. And if you don't even know what I'm talking about, that's okay. We will go all over that. Um, so there's tons of tools that you can use to write Python scripts. Normally, when you download Python onto your computer, you get what's called the idle editor, which is the built-in called development environment for Python. We are not using that. We will be using something called Jupyter Notebook. The website that hosts our course, my GeoHub, has its own version of Jupyter and its own version of Python. So you don't have to install anything. Everything is run through the web browser. And what's unique about Jupyter is that it is run in cells or short sections of code. And this code can be edited and ran simultaneously while you are editing another section of code. And you can run certain sections of code as you need. So what makes that unique is that if, say, you have a section of code that takes 8 hours to run, and you had a mistake in a section that only takes 5 seconds to run, you don't have to rerun it for another 8 hours. You can just fix the short section and rerun that section again. And the other thing that's unique about this is it's platform indifferent. And what that means is that you can run this on a Mac, you can run it on a PC, you can run it on a Linux machine, if you have a Raspberry Pi, stuff like that. It's very nice for that. So normally, if you were to open up Jupyter, I'm not going to have you guys do that with this. I'm just going to give you kind of a brief overview of what you'll be seeing once you start opening this. Jupyter, when you open it for the very first time and you're not opening a script up, it will open into a file explorer. And yes, what was the question? Oh, I'm sorry. I'm sorry. I saw that in the chat. That was for someone else. Yes, so you can create scripts, create folders, and simple files inside of this. So some examples of this, if you were to click the new button inside of this, you can create what's called a new notebook. This is just based on the Python 3 library. There's a lot of other options in this here. We will not be using those options. R is a different language built specifically just for data science. You can't do a lot of other things that you can do in Python with it. And all these other environments here are built for different types of tools. I will not necessarily be going over those, but you might use those later in the future. You can create folders for organization, and you can also launch a terminal. Some of you may know this, again, like the command prompt or PowerShell. Basically, this is something that you would use if you need to install something, like a library, for instance. You won't have to do that for this. My GeoHub will have all of the tools and everything that you need installed for the scripts that we'll be testing today. This is kind of where you're going to be working a lot. This is when you are inside of a Python notebook, you will have these cells here. And what you will be seeing a lot of times is this section right here is where you will be typing code. This right here. So this is a text box, and you can select the cell by clicking outside of it right here. And you'll know it's a code box that you enter code into because it has an input on it. That's what this in means right here, this IN, right? And you type code into it, and you can create other cells, or you can add as many lines as you want into this one cell. So there's some hotkeys that I'll give you here. B, A, and D. You don't have to remember or memorize these necessarily, but these are helpful keys that you can use if you want to create or delete cells. And the reason that you would want to do this to create something maybe say below or above is say you have a section of code that you're running, right? And maybe you want it to do something after. Generate a new cell, and you don't want to have to rerun this code again. Maybe say it took a long time. Generate a new cell below, and then boom, you can type in the new code that you want to run that works with that existing data that works from this. So data can carry over between cells. Maybe say you need to restart again and you need it to do something beforehand. You can press A, create a cell above it, and then type in your code into that. If it's getting messy and you've added too many cells, you can delete it by pressing D twice on it. Again, you don't need to necessarily have these memorized. If you open up the cell menu, all these options are there. So the last couple of things I think I'll go over here are markdown. So what's kind of unique with Jupyter is you can separate out your code and organization into two different types of cell types. So these code cells that I was talking about is where you do the heavy lifting. That's where you're going to be running your actual code. But you can organize it with pretty titles, lists, and so on and so forth with a different style of syntax. I will not be teaching that in this, but you can look this up. It's a very simple syntax if you want to create easy ways to organize your code. So you can, for instance, create a title or a list to organize your code and say, this is what the next 5 sections of code do. It's very helpful for yourself. It's like if you were to use comments inside of code, but it's in a way prettier way. But yes, remember that these sections right here are the ones doing the actual work. These ones right here will not do anything in terms of Python. So To run the cells, if say you have something happening, right? So say we just do 1 plus 1, right? The most simple math task that we can do. To get that to run, you can either press this button right here, or if you press Shift Enter, it will cause that cell to run all of its instructions. And then you get an output from it. So you have the input up here and the output right below it. After you run a cell, it will create a new one automatically underneath it. So as you do work, it will keep generating those below it. Excuse me. And remember that code cells run according to Python rules. Markdown cells have their own rules. Markdown cells do not will not cause a program to crash because they don't run according to Python rules. So kind of a quick little tidbit here. I'll remind you guys for all of your sessions, but make sure that when you're done with the interactive scripts that you close the session after. The reason that we do this is my GeoHub has a limit to how many scripts you can have open at a time. My GeoHub calls this sessions. And you will not be able to run the last activity unless you terminate the previous ones that you've done. So you do this just when you're inside the script, and the top corner here, there's a terminate session button. Just click that and it closes it, and then you can close that window out and come back again to run it again if you want. If you run this on your home PC, if you download Python, download Jupyter, and do all that good stuff, you can run as many of those as you would like. Just be careful doing that because you can overload your PC if you're not careful. So let's go into the basics of programming. So to reiterate, programming is the act of giving instructions to a computer, right? And these instructions are interpreted in order. Do one thing, then do the next thing, and then give something or do something else. But it will always happen in sequential order, one after the other. There are some caveats to that with Jupyter Notebook because you can run these cells out of order from each other, but everything inside of those cells will run according to this rule. So the overall philosophy here that we're going to kind of look at is, since we're not computer scientists, right, we will need to borrow ideas whenever it makes sense. So if you see an implementation found online, if you see something that someone else uses, feel free to adapt that to your method of doing this, right? Try to make things as simple as possible. If you have a very complex implementation, you may need to rethink that. So that also includes platform independence. So if you remember earlier, I had mentioned that these things can run, Jupyter scripts can run on any type of machine that has a web browser. Make sure that your tools that you generate are the same way. Talking about data justice and accessibility and fairness of data, tools can be the same way. You want to make sure that those are accessible to everyone. So there's a book called Zen of Python. It's made by Tim Peters. He's a very famous developer of some Python libraries. And really the key takeaways from this are the readability of your code. You want to make sure that you understand what you are doing, so that you can look at it at a glance and have a pretty good idea of, okay, this does this, then this does this, and so on and so forth. The implementation, you want to make sure implementation is easy. If you feel like you're talking about an evidence board trying to explain your implementation of whatever analysis that it is that you're doing, you might want to rethink it maybe, because it might cause a lot of room for error, and that will give you a lot of headaches. So getting into the technical session of this. So syntax, again, it's the grammar of the programming language, right? So it's how the computer interprets what you want it to do. It's important to know that the computer will always do what you tell it to do. What you tell it to do and what you want it to do may be two different things. So thankfully, in Python, the syntax is regarded as fairly simple compared to a lot of languages. There's a lot of things that are done behind the scenes that are implicit that you don't have to type out. So It's kind of important to know that if your syntax isn't right, most times your program won't launch at all. And I will give you a lot of examples of common errors that can happen with this. So the first thing that you'll do in every script is you import libraries. So this will be in almost every script that you create. This has the syntax of using the import word command and then a space, and then you put your library name. And I'll give some examples towards the end of this, and you'll get to see this in the interactive scripts. Think of libraries as extra tools that you use to supplement the tools that you currently have, in this case, Python. Some common libraries include SciPy, NumPy, Pandas. Some of these are shorthand for other words like numerical Python. And really, if you think of Python as your desk that you work at, libraries are the tools that you use at this desk. So Python makes it easy to work on things, but the tools make it even easier to do these things. Maybe you're trying to make a pretty graph, or you want to do some data analysis or management. Some examples right here would be import NumPy, import Pandas. The as suffix to this allows you to call this as a shorthand, and you'll get to see this a little bit later in a script so that you don't have to type out pandas every time you want to use a command. You can just type PD. Again, you'll see this in the interactive script, so we'll be getting to those here pretty soon. So variables. Variables are going to be the main thing that you'll be working with. They're the placeholders of all things that you'll be working with. Think of them as like containers. Basically, containers or variables will hold numbers, names, all sorts of things, maybe pictures, graphs, shapes, all sorts of things. And you basically give them a name and assign them to something. An assignment works in a very special way. So it's important to know, too, that these variables are volatile, meaning that once you end the script, the variables are ejected and deleted from memory. So unless you save something to a file, you don't normally keep those saved. So variable assignment works in one direction. So those of you that have taken algebra may think that maybe I could flip these two things. Python will not allow that. It is always the left will equal the right, not the right will equal the left. Say, for instance, you set x equal to y, right? So if x is 1 and y is 2, x will then equal 2 in this case. The left will always be replaced by the right. After a few times of trying this, you'll get a pretty good idea of how this works. So there's some basic data types that there's a lot of data types that exist, but they can be thrown into several containers. You have numbers, simple, complex, those with decimals, those without, grouped variables, and these can come in a set like lists, sets, tuples, dictionaries, lots of names for them, and we'll go into those more in depth in a little bit. Strings, characters, which are like the names that you may interpret. These may also mean numbers too. So for instance, numbers in a string lose their numerical value. I will go into that a little bit later. And then Boolean values. Booleans are just true and false. True and false, yes, no, 1, 0, on, off. And if you feel a little lost, that's okay. I think we will get a lot of this sorted out with the interactive examples. So we'll start with numbers. So for numbers, Python has 3 types of numbers. The important takeaway of this is that you will most likely be using the first 2 types of numbers. It has floating points, integers, and complex numbers. If you remember in your math class what complex numbers are, you may have remembered them being called imaginary numbers. It is the 2-part vector that's like 1 plus 2i. You won't be using those very often. You will, however, be using integers and floating point numbers. And really, the key takeaway of that is integer numbers do not have a decimal point. Floating point numbers do. And that's really going to be the key takeaway from this. There used to be a lot of other differences back maybe 10 years ago between how large the numbers could be, but that's not the case now. The key thing to know is that whether or not it has a decimal place. So in this example here, x and y are integers. They're whole numbers, integers. And the next number, this very precise one that I have here, this is a floating point number. And so we will do the interactive example here. So I normally would have you guys go into breakout rooms, but I think with the number of people that we have, I think we can keep everyone in here. So for the activity, if you go in My GeoHub and find under activities, the notebook tool, you can find a kernel file. This is the IPYNB file called numbers. If you click on that, it will launch Python Notebook. And I can show you from my side what that will look like. And I will work with this with y'all slowly on this here. So.
Hola, ¿cómo estás? Bien, ¿y tú? Bien, súper. ¿Me gustó? ¿Qué tal todo?
So, oh, I think someone's unmuted here. Y'all good? Okay. All right. So, in Tuesday's section here, I'll show you this here. You will have this section called Activities. There's an Intro to Python Programming Notebook. Go over to the right here, and there's a button that you can click that drops down. In that button right there, there's a Jupyter Notebook called Activities. If you click one of these, it will launch that. So in this case, we'll be launching the numbers notebook file. Let me know if you have any questions or if you don't see this. And I will slowly see Monday's lectures. It should all be published. Oh, you cannot see Tuesday's content. Okay. Here, why don't we do that? If you refresh the page, will you be able to access it now? Ah, okay. Okay. I removed that so that you shouldn't have to do that, but that's you may have to click through all of the things inside of Monday's lectures. Hopefully you don't have to do that now. Yeah, okay. And yours will look a little different from mine. You won't see some of these blank items here. Is everyone able to get the notebooks open? I take it that everyone has. Okay, so in this first script here, we will be playing with the variables and numbers. I will work through this very slowly, but you are able to work with this with me in this. So feel free to work ahead if you would like, but you don't need to if you want to stay and like work with me during this. And if you have a question, you're welcome to unmute yourself and ask me that question. So we'll start off here. So you can see some examples of what are called code comments. This is only able to do this within the code cell. And then we'll start by creating some names. So an example of this right here is the variable, and we are assigning it to the number 10. Yes, it is the numbers notebook. I think it's might be, yeah. And these will be kind of nice little notebooks for you to come back to if you have like questions that you may need to reference for creating your own code. That's why I have them listed this way, so that if you need help with numbers again, you can come back to numbers. So now this number right here, if you run this cell here, right, if you click into that and hit Shift Enter, what will happen is you will not have an output from this. Python, if you assign something, you do not get an output from it. If you try to show this number on the screen, you can do that. You'll get an output. So if you try to do that, just call this variable by typing in the variable and not assigning it to anything. So if you noticed, I'm doing the exact same name here. It needs to be exactly the same. So if you spell this differently, if you change this to something else, it needs to be the same here. And then when you run this, you'll get the number back. Is everyone on the same page so far? Cool. So now there are some, oh, need some help? What's the, do you have a question?
How did you get into the my GeoHub?
So for my GeoHub, if you are signing into this,
Yeah, I already signed into my GeoHub.
okay, so it
But-
should be under your courses then, if you have a course
Okay.
that you're, so if you go into your dashboard
Mhm.
and on the left here, there's a section for courses.
Okay.
If you click on that, you'll probably have one that you're listed as a student for, I'm assuming. So
Okay.
I'm the instructor in this one, so I will not be listed as a student. And then you
Okay.
can click on this section here to get into your section. You
Okay.
should have it enrolled.
Yes.
And then once you're here, you should be able to see Tuesday's content.
Okay. All right.
And then this right here, if you open this up with this arrow, you'll have all these notebooks here that you can launch.
Okay.
So here, I'll go ahead and do it through my GeoHub one, actually. So it takes a little bit to launch, since my GeoHub is actually the one that's launching this. Yes. Do you have a question? Zahid? If you have a question, you're welcome to type it out in the chat, or if you want, you can unmute yourself for that. Okay, so yeah, so again, we'll just kind of go through that real quick. If you run this script here, right, you can get the number from it, right? And if you try to call that back on the screen, type it, this is a number. And make sure that you have these underscores here, and I'll show you why here in a second. Then you get the number 10 back. So now you have to remember that Python does not interpret phrases the same way that we do as people. So Python does not know what to do with spaces. So say, for instance, you run this script right here. Python will throw an error and will say invalid syntax. Python does not know where to assign this number 10. Does it go to number? Does it go to a? Does it go to is or this? And there's some other issues that come up too. Certain words cannot be used as variable names. If you notice in your Python notebook, the word is actually green and not black. This means it's a reserved word and it's used for special functions. There's a lot of words that are like that. A really good rule of thumb is if it's not black, a lot of times it has a special function that you need to understand. So like an example of this would be if you did the ampersand and said like, hello, this is totally different. You can't use special characters when you're naming your variables. And yeah, I gives you some examples here. You're free to look at those. But we'll go past that. We'll go to variable assignments and multiple assignments now. So like I said earlier, variable assignment only works in one direction. So if you try to assign 10 to this as a number, algebraically, this would make sense. However, Python reads left to right. So you can't change the number 10 to something. It will always be the number 10. That's important to know when you're creating your variable assignments or you're assigning things to each other. So in this example right here, try to create two variables. You can give them whatever names. I give you examples, and then assign them to each other, and then call back both variables and see what happens. So I will work through this somewhat slowly, and then we'll kind of circle back and see how you guys are doing. And if you just press enter without pressing shift, it will create a new line. And you can have as many lines as you need to between stuff if it helps you organize. And you can place spaces between things. You just can't have spaces between variable names. That's all. Okay, so this is what I have here. So first we're creating A, making it 1. We're creating B, making that 2. And then what's happening here is I'm saying B should be equal to A. So when I run that, I don't get any output from it. So we'll look at both variables here. So normally, if I had just done the beginning section, it should be 1 and 2 that I get back. We can call back both of these by calling each one in succession with a comma between them. So you would do A, comma, B. And then if you run this cell, then it gives you both outputs back in the order that you asked for it. So this is A and this is B. And y'all are able to see my screen fairly easily, I assume, right? Numbers.ipynb does not load this page. Uh-oh. Is this script not loading for anyone else? Oh, that's good to know. Oh, it is loading. Okay. Have you, real quick, when you have this open here, okay, it's loaded. Okay. If you're clicking Jupyter Notebook activities, it will probably bring you into this, well, not this page here, but here, I'll show you. It'll bring you into the File Explorer. Okay, yeah. So real quick, if you end up on this page here and you're very confused as to what's happening, go back. You may have clicked on the actual Jupyter tool itself. That launches it into that File Explorer I was talking about earlier. If you click on the scripts, it should launch the script. Let me know if it doesn't or if you have an issue with it. Okay, so now that we have A and B, we notice that A is equal to 1, and so is B. So we changed what B was by setting it equal to A. You can do this through a lot more complex functions. We won't really show those. If you've used like a TI calculator, you'll know a lot of the rules and like conventions that will come from this. One thing that you can do to clean up your code is, if you noticed earlier, we can use commas to separate things. Commas, you are able to separate variables and you can assign them in multiple fashions on the same line. So an example of this here would be variable 1, variable 2, and variable 3. So if you notice, variable 1 will get assigned to 10, and I can add spaces here to help you see that. Variable 2 gets assigned to 55. Variable 3 gets assigned to 2.55. and so on, right? So you can call these back just like you did earlier, and then you get your variable outputs in the order that you asked for it. And this is important because certain things for data science commands that you do, you will get more than one variable back. So an example of this may be you ask for the coordinates inside of ArcGIS for some sort of geographical data. You will get a latitude and a longitude. And that gives it to you as a group. So the final lesson on this, I talked about earlier with number types. You have different types here. I'm only going to show integers and floating points. What's important to know is that Python will dynamically change those. One will go into the other automatically, but the other does not automatically go into the other, if that makes sense. So what I mean by this is that integers are the simpler type, meaning that they don't have a decimal place. So when you create it, an integer has no decimal place, but a floating point does. So if you look at the types for this, you have the integer type and the floating type. And what's interesting to note about this is that an integer can become a floating point very easily, natively in Python. It just adds a bunch of zeros to the end with a decimal at the end. But going the other direction, Python doesn't know if it needs to round up or down, if it needs to just remove everything past the decimal point. So a lot of times you have to decide what you're doing there. So if I flip everything, now you see that the integer is now a floating point and the floating point is now an integer. A lot of these things that you learned, you will not need to really remember these. These are just important so that it's in the back of your head when you're using functions. Because some functions request an integer, some request a float. And if you get these errors and you don't know what's going on, it's because it specifically needs that type of number. And there are easy fixes to change that. So, and I think that's the end of this here. So that's the end of just the numbers portion of this. So like I said earlier, we will terminate this session by clicking this button right here. It will leave the page and then it'll take you back to your dashboard. And then you should be able to go back to my GeoHub if you need to. So we'll talk about the next data type here. So, oops. So we have grouped variables. So if you remember when we assigned those variables, you could use commas to create groups a little bit easier, right? If you group those with parentheses or some sort of brackets, you can create a more unique group that can all sit inside of a single variable. This would be similar to like something like Microsoft Excel. So like a table or a matrix. They all have lots of names. The one that you'll be using a lot is called a list. And a list is just as it sounds, an ordered number of things. Could be numbers, names, coordinates, whatever, pictures, could be anything. There are lots of other like data types for grouped variables that exist. I will briefly go over these, but the one that you will be using the most is lists, and you will use later a more advanced form of dictionaries and lists called data frames. So for group variables, there are groups, and then within those you have what are called tuples, lists, sets, and dictionaries. For the most part, these are all going to do very, very similar things. They all just have minor differences. So for instance, the difference between a tuple and a list is that a tuple is unchangeable or unmutable or immutable and ordered, meaning that the first item that you assign is the first item that is in that list. And the order matters. If you rechange the order, the list changes. These are denoted with soft parentheses, or parentheses or soft brackets. And immutable means that if you want to change the tuple, you have to rechange that entire group again. However, with a list, they are mutable, meaning that you can change just a single thing inside of that without having to recall everything that you need to re-add to that list, if that makes sense. And let me see if I can leave that up. And I'll kind of pause here if you have quick questions about this. And then you have sets. Sets are, think of it simply as a bag of marbles. Nothing is ordered in it. You can't figure out what the order is inside of a bag of marbles. And if inside of that bag of marbles, you can only have one color of each marble. Sets can only have one occurrence in that list, meaning that if you were to create a set with the number 2 twice in it, it will only have 1 2 in it. So these are important for if you're filtering things out inside of your data. You use these as like a set to filter out things that you need, or if you need to tag things, stuff like that. And dictionaries are last. And I'll kind of go over these here in a bit. Oops, let me fix my, okay. Dictionaries are unique in that they are like a list of lists. The only thing that's unique about them is they have what are called keys. So instead of calling the first or second thing in that list, you can say, I want column 1, and then I want the first item. And those columns or rows, whatever you want to call them, can be called anything. So you could call it, I want the first name, for instance, or I want the second age, right? And you can call them whatever you want. You can have as many of these as you want. So if you heard earlier, I had talked about an index, and that's how you like call certain items from within that variable. So say you want just one number from that list. You need to know where in that list it is. Computers are very unique in that they start counting from 0. They don't count from 1. So in this example right here, let me get out my laser pointer. In this example, we have a set of words. So this is a list of letters and numbers, right? It spells out the word justice. But the very first thing here is item 0. And then it goes to 1, 2, 3, 4, and then all the way up to 8, even though there are 9 items here. So this is because the 0th item is the first item for us. And that's just because the way that we count versus the way that the computer counts. So if you were to call this, you would use hard brackets after the list to call the number for that. So we'll open up the matrices interactive example, and you'll get a much better example of like how these work. So let me open that up with y'all. So matrices. Let's terminate that session. I forgot to do that. So I will open that with you guys. Okay, so I will work with this with y'all, and if you would like to try it with me, you're welcome to give variables different names. You don't have to follow the same naming convention that I do. The reason I give variables those names is it is easier for you to follow and understand what I'm doing. So let's try this with a tuple first. So I'm going to be creating a tuple, so I can just call it A and then equals open parentheses. So if you notice, Jupyter creates the open and end parentheses. So you just need to type out the values that you need. And then you will separate them out with the commas, just like you would with the grouped group variable assignment. So in this case, it would be 1, 2, 3, and 4. And if you call back this in the same section, you get everything inside of that tuple. If you want just a single thing from that tuple, and feel free, by the way, if you have issues in chat, go ahead and post it and let me know. I can see the chat in another window. So if you want to call back just a certain thing from that tuple, you would use those hard brackets that I mentioned. And that's going to sit right next to the variable. So if I wanted the very first thing in that, I would call item 0. That would give me 1 here. If I called item number 1, which is the second item, I would get then number 2, which is the second thing in that list. Hopefully that makes sense to everyone. Now, earlier I had mentioned tuples are immutable, so you can also use this to try and change a certain item within that list. So say I want to change the first item and I want to make that 0 this time. I get an error. Now, why is that? That's because of the immutability that tuples have. So really what this means is that if you have a tuple, they're optimized for speed. They're not that much faster than lists, so there's not really any reason to generally use these. I just want you to understand what they are and how they work, because they can be used in a lot of functions. And if you don't understand what the difference between a tuple and a list is, it may cause you some grief. So tuples are good for if you have a group of variables that will not change and you don't need to change it. Just because of the speed and the way that they operate and work. So now let's try it with a list. Let's do all the same things, but with a list this time. You can use the same name. It will change the variable type, just like Python would do. So now it's a list. If you call it back, you get a list. And the reason that I know that this is a list is not only because I named it using the list conventions, it's because it gives me these hard brackets back. So you can tell that it tells you what it is. So soft brackets or parentheses means it's a tuple, or just a pair, sometimes is what it can be called, or a list, which is the hard brackets here. So if you try calling something back, it works the exact same way. Get 1. But because these are mutable, if I change the first one to be 0, I don't get an error. So now, if I call this back, if I call back the list, if you notice now, the first one is no longer number 1. It is 0 now. And this is going to be a lot of, you'll be doing a lot of this, like in your data science, most likely. There are more advanced functions for this that we'll go over that's part of the pandas library. That'll be towards the end of this lecture. There's 2 others here. So there's sets. Same thing, we can create a set by using the set function. The reason you don't use curly braces will be shown right after this, actually. So sets, I apologize for that. Sets, you need to give them a list. So this was a syntax error that I forgot, actually. So you have to give a set a list inside of it. And then it converts that to a set. So now if you try to call that set through an index, it gives you an error. And the reason for this is because there is now no more order in this. You have no idea what the order is. You just know that something is in that set. So let's see here. Whoops. Turn off my camera for a second there. So for mutability, you don't change them the same way. You can try assigning it through an index, but that won't work. So if I do a 0 equal to 0, it doesn't know what to replace. It doesn't even know how to assign that. It doesn't know what to work. However, if I do a dot add, and then I add the number that I want to add, in this case 5, and if I call it back, now 5 is a part of that list. Note that if I were to change this to 1, nothing changes on this. because 1 can only be in here twice now that it's already in here, or in here once now that it's already in here. I can run this as many times as I want, and it will never change that because I can't. A set can only have that happen once. So dictionaries are going to be the last one. This is going to be kind of like a baby version of a data frame. You may have heard of data frames through like maybe a Python video or something like that. Dictionaries, in this case, are done using hard bracket or not hard brackets, curly braces. And what it is basically here is to make this a little bit easier to read. You have a dictionary that I'm creating, and that is equal to open brackets. Then it's the first key. So the key is the label for the first list. And then in that list, I have names, comma, then the next key, a colon. So and the colon separates the identifier and the list. And then you have another list for that. And then what happens is this gives you a way to uniquely call values without having to use strictly numbers. And what I mean by this is, say, for instance, I have a dictionary, and say I want to know all the first names that come up in that. It will return a list of all the first names. So now I have a list of all the first names. Say I go even further, and I want all the first names, but instead of all of them, maybe I just want the first one. So it will give my name in this case. If you call a dictionary without a key, or if you try to do this out of order, so say, for instance, you do this and do 0, it will not know what to do because neither of these right here are 0, right? So it doesn't know what to do. So technically speaking, if I change this to be 0, should work. Oops. So that would be number quote unquote 0. That's pretty much it for the matrices for this. There's a lot more stuff that you can do with these. And towards the end of this lecture, I'll go into the easier to use function types like data frames. So I will terminate this session. Leave that, leave that open, and then we will continue on to our PowerPoint. So the next variable type are characters and strings, and characters are simply put the buttons you see on your keyboard. They're numbers, letters, special characters. Anything could be considered a character. Characters have a different numerical value than what's associated with like the number, basically. So they have their own number that's associated on the keyboard. These are called the ASCII values. What's important to note about this is that, say, for instance, you read some data online, and your program interprets the numbers as strings, and it tries to perform operations on those. You will not get the data values that you expect from it because strings work differently on that. What I mean by strings is characters that are strung together to create these strings. So these are basically just matrices or lists of characters. So what you saw earlier when I had those names inside of those quotes, those are just unique types of matrices or lists that have characters in them. And what's important to know is that strings, you can't change them in place without special functions. So you can't just assign the second term in this. So some examples of this here, you can use single or double quotes. We will be using double quotes for all of this. So this example that's shown on the right here, where it says my string, oops, I'm not wanting the pen, I want the laser pointer. This right here, this is what we'll be primarily using for this. So, and I'll show you some examples of this here. So we have another example. You can go back to your breakout activity, and we will load up strings. And this will be the second to last portion of this. And then I'll kind of have a section for questions later towards the end of this lecture here. So for strings, we have lists of characters. The same modification techniques can be applied to these. So let me close out my PowerPoint. And if you have questions, feel free to ask. So first thing, try creating your own name inside of this. So I'm going to let y'all try and do this first on your own. And I will, in the next few minutes here, I will join in with you. I want to see how y'all do on your own. And let me know if you have questions or issues. And if I'm going too fast, let me know, and I'm happy to slow down and kind of reiterate some more concepts. I'll just leave it on this for now until y'all are. So I'll give y'all a couple minutes to work on this. Then I believe we are coming up to our break soon. Yeah, it will be at 10:30. So probably after this exercise, I'm going to cover maybe a couple more things, and then we'll take our break, and then we will continue with the lecture. So where can we use strings? So let me load up this here. So what do you mean? Like where can where is it applicable? Like what? Like why are we learning it? I guess. Or do you mean? Yeah. So it's applications. So okay. Yeah. No, that's a good question. So strings. This kind of depends on the context of what you're doing. So the reason I bring up strings is several reasons. One, certain types of stream data may come as a stream. An excellent example of this is, say you have a sensor that has GPS data. Say maybe you're doing some field research and you're using a GPS sensor. Data from a GPS device usually comes as a string that you have to interpret and separate. You probably won't be using this that much. I think most data scientists, unless you're using like text mining, will not be using strings that much. However, you may use text mining. Maybe you are analyzing contracts for energy research or for water research or something like that. Yeah, so that's why. Another thing too is if you have inside of an array or a table, and you read data from a file, the computer's not always smart enough to interpret that something is a number, and it may interpret it as a string. And it's important to note that strings lose their numerical value when they are strings. The computer can change that But if you are having issues trying to compare, for instance, two strings, Python doesn't know what to do with that like it would two numbers. So, and this one's pretty short. That's why this one's pretty short, is there's not as many applications maybe for like the data science that you'll be doing. I just show a few examples here because you might, for instance, have stream data that you may need to split. Or if you need to query a database and you need to grab that data back and there's no programming interface for it. This is the method that a lot of programming interfaces or APIs use. It can be used for extracting numbers or text. Yeah. So like I show that in the later example, there's an example here where I convert a string back into a number. So say you have a string with the number 500 in quotes, right? You can convert that back to the number 500 so that you can use it as a number. But this is a lot of this string modification, string changing and stuff like that is a lot of ways that application programming interfaces, APIs, are developed for how they query databases. And I think you'll go over this more later, I think in tomorrow's session with querying databases. But you usually have to send some sort of request and you have to interpret that back. And when you interpret that back, you need to know, how do I split this number up that's coming back to me? Because unfortunately, a database, when you request information from it, may not always send it to you in a format that's just all easy to grab numbers that Python knows what to do with. So sometimes you have to do a little legwork on separating it and so on. So like an example of this here, so I have a sentence here that I'm splitting, but say for instance, we'll call this data, right? So we'll have data here and say it's maybe temperature, and it's got a comma, maybe it's humidity, and then maybe it's like, you know, some sort of latitude, and then longitude. I don't judge by latitude and longitude that it's giving here. That's probably not correct, but so say maybe that's the data that comes in from a database, right? That's so for hard brackets and why we use that for indexes, that is just Python's rules. I know that's probably not a satisfying answer, but that is how Python interprets that. It's always going to be a hard bracket, and that's going to be the same regardless of whatever type of list or string or whatever it is that you're using. So say you have data that comes in, right? And say we want that data to be split up into something, right? So if I say split this, so set it equal to itself, right? And I'm splitting it, but what I need it to split by is, if you noticed, I put these commas here. So I want it to split every time there's a comma, and I want that to make a list out of it. So if you do that, and then if I get data again, now I have a list of these numbers. And if I want to grab the first thing in this list, then I would just say 0. And then it would be 24. So this one comes up as a string. I'll show a little bit later in this some of the like built-in functions. You can change a string using what's called the I think just int command. I'd have to look again what I had written. And it will, Python will attempt to convert that number. So, and there's tons of other things that you can use. Yeah, you can. And I'll show some examples of like what happens after that. So say you have a file that imports, right? And it is not interpreting it correctly. You can apply that split to those pieces of data if you need to. So very briefly, kind of as we're coming up to the break here, I think this will be a good place to stop. And I'll just kind of answer some questions before we take our break. Has anyone seen like what a .csv file is? I presume most of you know what Excel files are, right? And like how Excel spreadsheets work. So with what are called CSV files, they're kind of like a more rudimentary version of Excel files. They use commas to separate their data out, right? So CSV stands for comma separated value. And normally Python is pretty smart at interpreting that. When we use the pandas library later, pandas is able to interpret those commas pretty accurately, and a lot of times it can almost automatically detect the variable types that are in this. So for the most part, these tools that are here will not be needed if you're just analyzing data. But you might need to know this if you are creating your own tool and you need to understand what's happening behind the hood of like what's going on there. So like pandas, for instance, when you create a data frame from a CSV file, what it does is it looks at the first row and it does exactly what's happening here. And what it actually does is it goes a step further and it converts these into their respective numbers. So in this case, this would be an int, or an integer, and these would be floating point values. Nothing more than that. So I'll show that example a little bit later as we get closer. And yeah, so to circle back real quick again on why we use the hard brackets versus the soft brackets. It just comes down to how Python interprets that. So soft brackets are used for exclusively for calling functions. So if you noticed earlier, I had that thing where we did the set and bracket or parentheses, right? So I will explain functions later, but parentheses are used for functions and doing tasks. Hard brackets are used for indexing and calling variables. So say we'll give you an example here of what will happen if you use the soft brackets. So if I have a list, and I say it's 1, 2, 3, 4, right? And if I try to call that back with a 0, what will happen is it will say that name A is not defined. A is obvious, or not A, I'm sorry, whoopsie. A is definitely not defined. Yes, so list is not callable. Callable means it's not a function. It doesn't do commands. Python interprets soft brackets as you have some sort of command and you're giving it inputs inside of this. Hard brackets interpret it as I need something out of this. Does that make sense? And I'll kind of show that here a little bit later. So we'll talk about functions and all that. There's a lot of things to cover for Python, so I kind of want to make sure everyone's up to speed with where we're at. Does everyone feel fairly comfortable? I know it's a bit overwhelming. There is a lot to learn for this. And believe me, no question is too small for this, so. Yeah, sure. So say I have a sentence, right? And so say I have a sentence and I set that equal to hello and welcome to data science, right? So if I call that back, that creates just a single string for this, right? If I split this, so to do that, you can't just type split and then do that, right? So this is an example of a function right here. I'm not calling anything out of this. It is a function that has no inputs right now. You set it equal to itself, but split. And if you don't give it any sort of separator, sometimes it's called a delimiter, but it's the separator. So in this one right here, up here, I used the comma, but you can not specify one. And what Python will do is if you don't specify one, it will split it at every space. So say I do that, and then I call back sentence. Now I get all the words from that sentence. Let's say I want to call a name or a word in that sentence. So if I want to call the third word in this, I will call item 2, and then I will get welcome. Now, to take that example a little bit further, say these are types of data that come in, maybe separated by spaces, and maybe you need a certain character from this and it corresponds to something. Using the sentence example, what if I needed just a letter from this? So say if I'm in welcome, say I want the first E of that letter. I can call this again to go within that list, right? So now with welcome, I would call item 1, and that will give me the letter E. So in this, it will be the third thing, item 2, and then within that, it will be item 3, and then item 2 within the third item. And this concept's called nesting. I will explain that later. That's kind of a crucial concept if you want to create anything that's like fairly complex. So does that make sense? Cool. Cool. So real quick before we go to the break, I'll kind of show another example here of like what may happen. GPS stream data. So say you have like GPS stream coming from a sensor. This is not always usually what comes from like a lot of data science sources. This is like if you're doing your own research and you have your own tools that you've developed and you want to be on the forefront of like, something like that, right? Say you have a bunch of GPS stream data that comes in. It has a header, so it's got some things that come in, maybe a hashtag, and then it has, coordinates, right? And then it has another hashtag, and then more coordinates again, hashtag, and then it has like some sort of universal time code or something like that, right? An example of separating this would be if you were to do data list. So you don't have to set it equal to itself. Data list can be equal to GPS stream dot split. Get back the data. Oh, whoops. I forgot to call the separator. So when you call it back, sometimes it may use a different character that's not a comma or a space. You can use anything for that. So in this case, it's separated by hashtags, that's just one example of it. I don't think GPS stream data actually uses that, but it does use unique separators like that. So that's just one example. For searching stuff online, you will use stuff like this a lot. Like if you were building your own application programming interface for a database. So this is very important for building and deconstructing search queries and the results from those queries. So I know it doesn't normally seem like something that you would traditionally learn in data science, but it's surprisingly relevant. Any other questions before we head to break? That's a good question. So you can if you want. So like say for instance, I want to split this again here. You can put the space in there and it will still work. Oh, whoops. Sorry. Yeah, so you can put the space in there and it will still work. What Python does is if you want spaces, if you don't put the empty quote strings, it assumes it will be an empty white space. Does that make sense? So no, you don't have to put that in there. To answer your question, no, you don't have to. You can, but you don't need to. Cool. Okay, I think it is about time for the break. So if you remember, the last thing that we were working on was the interactive example for strings. We were modifying strings and modifying characters and stuff like that. The next thing that we will learn is modifiers, or not operators. If you've used a TI calculator, then you should understand kind of the basics of like these operators that will happen here. And these are just methods of manipulating the data. You may have seen some of the examples that I've already shown in this. I can show examples of these on screen for you, but I don't have an interactive example because there's some other stuff that I want to show first. So you have your standard operators like adding, subtracting, multiplication, division. Doing stuff like exponentials and certain types of division will be done a little bit differently. So I assume that probably judging on the fact that I think most of y'all are undergrad, but some of y'all might be graduate students, you probably took a math class over COVID and you probably had to do some math class homework online. Normally, when you do those, you would have to enter in like an exponential, like a 1 to the power of something using a caret. You don't do that in Python. It's a little bit different. There are different rules for that. So for instance, doing an exponential uses a double asterisk. That means that in this case, it would be 3 to the power of 4, and that would give you 81. Integer division is essentially if you round down or cut off the decimal portion of the division, so no remainder. So for instance, 3 divided by 4 is less than 1. It will always round down to 0. Modulus and mod is kind of an interesting way to get the remainder of something. So if you want something, an example of using this would be if you want something to run every third iteration and you're going through a loop, which I will explain later. That's another good way to do that. And the rest of them work fairly pretty much the way that you would expect it. And it works exactly the way that you see it typed here. You can type it without assigning it to something and you will just get the number back. But you can also assign it to a variable and you can also insert variables in place of these numbers here. Some of these things are different between programming languages, but for the most part, all of these are pretty much the same. And that's what I was talking about with like the use of the caret. What's important to know is that order of operations applies here. And if you are unsure or if you think that Python does something differently than what you're used to for typical order of operations for math, use parentheses. You can use soft parentheses inside of your calculations. So like soft brackets or parentheses to denote that you want something to be done first before it does something else. just like you would on a calculator. So if you used a TI calculator, or even like just a scientific calculator, you probably know what I'm talking about. Same rules apply in Python for that. So when it comes to operators, it's pretty similar to the same way that you would use a calculator with some minor syntax differences. So the next thing that we'll look at is Booleans and conditionals. So conditionals are your decisions that will happen inside of your script. Excuse me, sorry. Booleans are variables that just have two states. They either are true or they are false. This can also be decided as like it's on or off. This light bulb here is a fantastic example. There's no in between. It's either it's on, it's something, or it's nothing, off, right? This can be depicted in several ways. There's a lot of ways that Python can interpret Booleans. So for instance, a 0 and a 1 can also be interpreted as true and false, true being 1, false being 0. Think of it as there's either something there or there is nothing there. And these are very important because this is kind of the core of your decision processes that you will create for your tools, for like your programming, and like it's like the very core of this. And the way that you do these is so you can assign a direct variable, and just like a number, there is a literal true and false value, that these are reserved for just true and false values, right? Let me bring up my laser pointer here, actually. Oops. Okay, that's not helpful. Oops. I apologize. Okay. Well, that's okay. So if you assign it to that, then you can change it depending on what happens, right? So there are other ways to measure the Boolean values that occur in this. So an example of this is if you use what's called a conditional statement. Conditional statements are just simply a way to initiate a decision that happens within the code. So here, let me keep that open. And you initiate these. So you start here, right? And then after you start, you let's see if I have the laser pointer on that. I do not. You check to see, is something true? And this can be a variety of things. It could be a Boolean value, but it could also be a comparison. Is this variable less than 5? Is it greater than 10? Something like that. Is this name equal to this? There's lots of ways that you can do this. So when you check this, you have two options. It's either true or it's false. If it's true, it does something, and then it ends, and then you continue on with your code. If it's false, it does a different thing that is separate from the first thing. A lot of times this may mean it's just not doing anything. It does nothing. So maybe is it true? It does something. If it's not true, it doesn't do anything. And these are done what's called using an if statement. And the code that you run, if it's true, needs to be tabbed over. So this is what Python kind of like to focus on with its emphasis on indentation. So instead of having to explicitly contain that with like special characters, you just indent over the code under the if statement, as shown here, right? So this is a good example here. This right here is the conditional statement. If x is greater than 3. And you see that earlier in this example, I am setting x equal to 4, so that you know, yes, that is true. X is greater than 3. When that prints, that will say x is larger than 3. When I run this, this code right here will run, and you can see the output that I get is exactly what I would expect. Does everyone feel like they're on the same page so far? We'll have some interactive examples for this. No questions? Okay. Okay, so conditional statements can have more than one condition, right? So you can have an if, or an else if, or an else if. And basically what this means is that you can check multiple things in sequence inside of the same decision. And it's important to note that these decisions are checked sequentially. So remember, I mentioned the code looks at this from top to bottom, left to right. The first thing that's true will run the code that's true, and then it will skip every other condition and exit the conditional statement. So on this example here on the right, if I have x is equal to 5, right? I accidentally flipped these right here, so you'll have to ignore that. But it's greater than 4. It is also greater than 3, but it runs the greater than 4 code because it's the first one that comes up. So when that's the first one that comes up here, it skips these next two things that happen here. So say, for instance, if I set this to x equals 4, it would skip the first one and run the second one. If I set x equal to 0, it would skip the first two and do what's called the else statement. The else statement is your catch-all that if you still want it to do something, but not have a specified condition that is met. So say you have two conditions like I do here, and what if it doesn't meet those, right? What if you have something that's outside of that? Well, you can use an else statement to catch that. So say, for instance, it's, okay, well, I don't know if it's bigger than 3 or 4. Okay, well, I'm not sure then. So we'll look at some examples here, and I've kind of highlighted these so that you can kind of understand the different terms for this. And this is stuff that you will be using a lot more often. When I talk about indentation, code that is below an if statement has to be indented until it is done. And between an if and an else statement, you can't have anything that's not indented. So if you want, for instance, to set a Boolean value to false, in this case it would be 0, it checks to see, is it true? Obviously it's not, so it will go to the next else statement here. It does this item right here, and then it exits. Now notice that I say that Boolean is equal to 1 after. That's just something I wanted to set. But because this happens after the if statement, it will never do this. Is that pretty clear so far? Yes. So the difference between an if and an else if, or an elif and an else statement. An elif statement has another condition. It's like if you were to say if and then if again. There is a difference between saying if and if again, though, than saying if and else if. So an example of this here, I'm going to take my pen here. All of this right here is all one statement that it checks. It checks, is it greater than 2? Okay, we don't know. Is it greater than 4? Is it greater than 6? And if it's none of those, the else statement does not have a condition. So you don't specify something with it. So if it's not less than 2, less than 4, or less than 6, then the else statement will run. So the difference between elif and else is else does not have a condition that it needs to meet. It's the no conditions are met. Elifs are basically if within that same statement you want one of those things to happen, depending on the conditions, you would say if greater or if less than 2, if less than 4, if less than 6. Does that make sense? Okay, cool. Yeah, and we'll have some, I think, some interactive examples, and I can show some examples of how it works here. So watching the code like be typed and run and see how it works, I think kind of helps with that. Um, so we'll talk about another important part of Python, loops. So say you have something that you want to do to a number or something that you want to do to a list. That means that you have to do something over and over and over and over. And does that mean that you should type that same command over and over with a 0 and then with a 1 and then a 2 and a 3? No. That would be very tedious and would take an extremely long amount of time to do that. Programs give you the functionality to be able to call back the same command over and over a set number of times or over a list. And what I mean by this is, so say, for instance, you wanted to do something 10 times, right? You can use a loop that says, I want you to run this code that's indented below me 10 times. Or you can say, I want you to run this until the output is greater than 10. There's two different ways to do that, and that's essentially what the difference is between a while and for loop. A for loop, when you call or start the loop, it will have its exit condition predefined, meaning that if you say, I want a for loop that runs for 10 times, so for a number within the range of 10, it will always run 10 times regardless of what's happening in that loop. A while loop, however, just checks for a true false condition, and that's it. So it's like a conditional statement that is also a loop. So loops have three parts to it. They have their start, which is the call. And this is usually where you type like while something or for something or something like that. Then you have the body. This is what's indented over. And this is the code that you want to actually run. And then you have the exit condition. And the exit condition for this means, how does that loop know when to stop? So for loops, like I mentioned, they are called for loops. Usually iterate over something like a list. So say you have a list of numbers, it will go through each number, and once it reaches the end of that list, the loop is done. It's cut. It can also go over just a set number of times, depending on how you program it. The while loop is a little bit different on that. That can change dynamically within the loop. So maybe this next set of examples here will give a kind of a good idea on this. So the while loop here on the right will run until I is at least 100 or greater. So what's happening right now is that I is slowly increasing. So this plus equals 1 is another unique modifier for operators. If you just want to slowly count up with 1 each time, you use plus equals. Minus equals also works for subtracting 1. This is great for counters or lengths and stuff like that. So what happens is in this loop here, you start at 0, right? And then the loop is called. And then once you have the loop, it goes through and does this a bunch of times. In fact, it does this exactly 101 time. Oh, no, it goes, yeah, it does it 101 times. And the reason for this, and the reason I wanted to show this is sometimes this is a common thing that you will run into when you create your own loops. You sometimes will not understand like, hey, why am I getting 101 and why am I getting 100? It's this if statement right here and this plus 1 plus. So sometimes you need a +1 to or a -1 to help you iterate through like a list. And I'll show that in the for loop here. Just keep an eye on that when you're doing that. I just wanted to show that as an example. But this iterates 100 times. And then the reason it takes 100 times is it's adding 1 to I. And then after it adds 100 to it, what happens then is now I, this condition right here, becomes false, right? You have to excuse my handwriting here. That becomes false. And then it exits. Does that make sense? It's probably making it more confusing, I think. But if you have a question, post it up in chat, and I'll come back to it at the end of the slide here. But so for for loops, they're a little bit different. So for for loops, you say for something in something. And usually what this means is you define how long that loop's going to run. So if you were to recreate the top one, you would just say for I in range of 100, and then set x plus equals 1. And that counts up x 100 times. And that does the same thing. For loops, however, the other thing that you can do is you can iterate over a list. So for instance, in stuff, this list that I've generated here, it's going to keep setting this variable x to whatever is inside of stuff. So at first it starts at 1, and then it starts at 2, then it starts at 3. And you'll see this in the interactive example. And it does this all the way until it reaches 9. Now, the reason that 9 is the output for this is once this reaches the end of the list, the last thing that x is set to is 9, because that's the last thing in this list here. And that's why you get that when you print that number out. The print command is just a simple way, by the way, to like print a number to a screen. Jupyter is nice in that you can just type the variable name and it will give you that number back. So let's turn that off. So we'll go to the next page here and we'll talk about what's called nesting. Decisions, loops, and lists can be put inside of one of another. Decisions and loops can be crossed between each other. So you can put decisions within loops, loops within decisions. An example of this is right here on the right. So say, for instance, you have a word called stuff, or a stuff string called hello, right? And that hello string has a bunch of different letters in it. Maybe you want to look at every single letter at that. And if the letter, right, so that's looking at every single letter, right, for I and stuff, because this is considered a list of characters. If that letter, so in this case, this is the letters that it will be iterating through here. If that letter is equal to L, then it prints out the letter. And when you set something equal, you have to say a single equals sign. If you are comparing if something is equal, you use a double equal sign. And that is just so that Python knows if you're asking or telling. And so let's see here. Let's go. So the reason it's called nesting is because this decision sits within the loop, or it can sit within another decision. And basically what happens is the only way that you can get to action 2 is through action 1. And then you can get to action 2, be it a loop or whatever. You cannot put loops and decisions within lists. It just doesn't work that way. But you can put lists within other lists. That is an excellent example of that is what a table is. So like Microsoft Excel, CSV files is a list of lists. So like, for instance, every row is a list of columns. So when you give a list of lists like this over here, an X and Y value, just like you would in Excel, like row and column, then you can get out what you need from this. So this right here is 0, 0, 1, 2, 1, 2. So if you were to call, for instance, in this case, 1, 1, you'd get brown as your return. Does that make sense? We'll go over this in interactive examples too. So. Okay, I think everyone's good. So, and I'll have time at the end for questions, examples, whatever y'all want to see at the end. Just let me know. So, remember earlier, I think someone had asked about why we're using hard brackets for our indexes and not soft brackets. That is because functions save the space for those soft brackets. Functions are essentially shortcuts in the code for complex tasks. So an example that I have on the right here is, say I want to do a bunch of complicated stuff. In this case, it's very simple for simplicity's sake. Say I want to take in this variable, I want to take itself and add 3 to it, and then return this variable back to the person. This function right here requires an input, and that input is contained within soft parentheses. So for instance, if I were to run this function that I defined, which is defined with a DEF, it adds 3 to 5, and then I get a returned output of 8. There are tons of functions within Python. You can custom define your own functions, but a lot of the ones that you'll be using will have those soft parentheses. And a lot of times they may not have an input. So for instance, I could have a function that just prints out words and doesn't require any input. And that's why you have empty parentheses. So like the split function, for instance, if you don't give it any inputs, it automatically assumes you want a space. I won't go real in depth on this. There's a lot more that you can learn about functions and kind of their superseding part classes. I will not be able to go into that. That's a much more complex topic than I think I have the time for. But they are a very interesting part that will allow you to really clean up your code. So an example of this is, say, for instance, you have this complicated set of programming instructions that you want in several parts of your code to happen at different times. Maybe it's within different if statements. Instead of typing it over and over, you define it as a function, and then you just call, right, or start the function within those sections that you want it to run. So I'll talk about some errors, and then we'll kind of get into like more of the fun stuff here. So errors that you can encounter as a programmer, there's syntax errors. These are pretty straightforward. You typed something wrong and it doesn't run. Most times this just means you forgot some sort of character like a colon, or you have too many spaces. One that's an issue with Python because it uses indentations. Python wants to make sure that you use proper tab spacing and not like space indentation. So don't put like 5 or 6 spaces to try and indent your code over. It does not like that. Logic is another one. So this is the program runs correctly, but it does not run, or the program runs, but it does not run correctly. So this is kind of a reiteration on what I was talking about earlier. If you give it a set of instructions and the computer correctly interprets those, it will run the set of instructions that you gave it. Now, whether or not what you want the computer to do and what you told it to do are two different things. That's a different story. This is what logic errors are. So an example of this is maybe you put a plus instead of a minus. And it's counting up instead of down, or it's adding this instead of subtracting it, or, and a lot of times, a greater than, equal than sign. And maybe you forget which one I'm supposed to use, or maybe you have to kind of think about the logic or something like that. And the last one is a runtime error. These are a little harder to track down. This is a combination of usually syntax and or logic errors, but these usually occur because and what makes these unique is that they will crash the program usually, but not on start. So maybe it's after it runs some code. So it will compile, run for a second, and then crash. An example of this is trying to access something that doesn't exist. Yes, it does. Letter case can cause errors. So what's unique about letter case is, so like for functions, for instance, this is case sensitive. If I were to add, like, so if I change up here at the top, so like, if this right here was a capital A, this would need to be a capital A as well. If I did not use a capital A, it would then, this would not run. It would just crash. Like it wouldn't even launch. Case sensitivity is also important for your variables too. So if you name a variable, you need to call it the exact same way that you named it, including the like upper lowercase letters. It's computers are very literal in that sense that it needs to be like explicitly stated. Because you can have a variable that is different with lowercase letters and then one with uppercase letters. And there's a lot of other caveats to that. So yeah, so that's really it for the errors there. So we'll talk about like some like kind of fun examples here of like libraries that you'll be using. And then later on throughout today, you will get to have some like real life examples of using like databases to download data from like the United States Geological Survey or through like energy building simulations and stuff like that. So so there are some special libraries and functions that you can get. The king of this is Pandas. Pandas is a library that deals with manipulating data. So what Pandas does uniquely is that it takes the list type that we learned about and the dictionary type and combines them all together to make this really cool, unique class that has a lot of built-in functions for cleaning up its own data. It also has the ability to save to files natively. Like you don't need to have special functions. You just tell it like, hey, save to file, read to file, give it the file name, and that's it. It's very simple. Pandas has two data types, a Pandas series and a Pandas data frame. Really, the only difference that you need to know between these is that a data frame is a series with more than one column. That's it. Whoops, I didn't mean to skip that. And then I give an example here of importing what the library looks like. So the library here is Pandas, and when I use the as, that's shorthanding this so that you don't have to call Pandas every time you want to use a function from it. So you'll see this in the examples here coming up. But an example of this here would be, say you have dirty data that has a bunch of erroneous values or bad values that are in it. Pandas has a built-in function to be able to clean up some of those values and remove them. Pandas has a built-in function to be able to plot its own data so that you can visually see it just like quickly at a glance, just like that. Pandas also lets you do a lot of data manipulation by looking at the end of a data frame, adding stuff to it easily, and managing it very easily. So this will be kind of like your home for this. This is what like almost every data scientist uses. It's even cross-platform, I think, between outside of Python. And so for Pandas, it's derived from NumPy, so which is short for numerical Python. And numerical Python basically is this library that adds the abilities to have fast matrix or arrays. They call them arrays in NumPy. The ability to like store data in big tables and be able to manipulate them in really fast ways. So an example of this is, say you have a lot of like geological data, right? Or energy usage data across a bunch of buildings, and you have a really large data array. it has short tricks that it uses to be able to manipulate that math if, say, you need to transpose it, say you need to multiply it, you need to do element-wise operations. This is where a lot of performance improvements come into play. It's also great for generating arrays with just simple numbers in it. Since Python, you would normally have to loop through and create a list. This is great for creating graphs and such like that. So if, say, you need an x-axis that goes from 1 to 10, you create an NP array that goes from 1 to 10. Easy. And then this shows like an example of this. There's another shorthand you can use for this. The shorthand can be whatever you want it to be, but it's pretty standard to use the ones that I've given here, because there's a lot of examples that use that shorthand. Another thing that NumPy works really well is you can easily implement math formulas with it. So if you're struggling with the built-in Python operators, you can have your own functions from NumPy taken place, and it just flows more naturally. And you use actual function names to say like sum, average, stuff like that. And NumPy's performance for this gives you the ability to do this on really large data sets without bogging down your computer a lot. And we'll use these later. You'll see a lot of this referenced later. I just want to give you all kind of like a brief breather on that. So a lot of things, computer scientists, anyone that does any sort of programming, it's very hard to learn everything at once, especially through classes. You will always have to be learning new tools. Yeah, I'll show you. Yeah, it's very easy to add and use these libraries when you're in your notebook, and I'll show you that. And that we'll do that here in the next example that'll be coming up here in a second. Many of these languages have large online communities where you can find tons of resources on this. I unfortunately will not be able to go really in depth on a lot of these resources, so I will be giving you enough to be hopefully interested and hopefully a little dangerous with this. But if you want to look online to see like, hey, how do I do this a little bit better? I saw, we talked about strings a little bit. Maybe I wanted learn a little more about that. Or maybe I wanted to learn about arrays or data visualization better. There's tons of stuff online. Great resources for this are usually going to be the official wiki, and all of these libraries have their own wikis that have documentation where they have all of their functions listed, examples that are nice and easy to follow, and a lot of times there's multiple examples, usually showing a situation where what you're trying to do. Stack Overflow, I think I have it as .NET. It's actually .com. Stack Overflow is a great website to just search if you have a question on something. If you have a question on something in Python or any sort of programming question, chances are someone's probably asked it in Stack Overflow. So you're welcome to search through it and look and see if someone's asked it and see what the answers would be. Another thing that you can do too is you can go and check out other people's implementations and code on GitHub. A lot of times people like to share their code because they want people to see how it's worked. People like improving upon it. And you're usually welcome to use someone else's implementations and codes and methods, given that you give them credit, and you need to check the licenses that they have too. So some examples of licenses I think talk about later. The MIT license lets you use and pretty much do anything with someone else's code. But there are some that are more like open source licenses that mean you can't use it for something that generates money, or you can use it, but you can't change it or modify it, without permission. So just some examples of that. There's tons of other sites for this too, but Stack Overflow, YouTube, Python Wiki, those are good starting resources that will probably get you just about anything that you need. Oops, 1 second. Okay, so we will be getting to kind of the fun portion of this, and I will stream this with you so that if you have questions or you want me to show you something, I'm happy to show you the functions that you want. Some of these will be gone over in the next activities, in the next lectures. But for today's activity, we will open the extras Python kernel. And then we'll follow along with the instructions, and I'll kind of work with that with y'all. So this will explain how to import those libraries and tools. Like I think someone was asking that in the chat earlier, as well as like some special functions that we can use, among other things. So let me do that without further ado. Discard. Yes. Okay. So let's open up extras. Right. Okay, so this will start off giving some examples of loops, and I will show you some examples of like stuff in here. But so this will be less of like what you guys will be able to type out and more of just kind of running the examples to see what happens. So, excuse me. In the for loop, for instance, we can see that I have this list right here, right? And you can change this to be whatever you want it to be. And then I have a counter. And what I do here is that for every word within words, the counter increases by 1. So remember that this right here increases by 1, right? And if I run this, then I get 4. If I were to change this here, and to put this inside of the loop, what this will do is this will print this multiple times. So now I know it starts at 0, then it goes to 1, then 2, and 3. If you want it after it counts so it has more natural counting, you put it after, and then it goes 1, 2, 3, 4. If you want a for loop to do a set number of actions, however, you can say within a range of something, and this will go from 0 to the number that you specify. So for instance, in this case, for I in range of 2 will run exactly 2 times. So it will run for 0 and 1, and then it stops before it gets to 2. So it's not inclusive of this number here. So when I run that, I just get the first 2 words on this here. And let me leave that chat open here. So if y'all have questions, y'all were able to open this one up, right? I assume. Okay, cool. Good. Okay, so it should be, so it's the extras Python notebook. It's inside of the activity section. It should be the top one, the extras.ipynb. This one right here. Cool. Awesome. So, and most of these cells should all be filled out. So if you just want to run it or change the values to see like how it works and what it does, you're welcome to do that. For a while loop, I'm including the Booleans that are inside of this. So this is a more complex example here, basically. So what happens is I have this Boolean that is called stay inside the loop, and I have it set to true. And then I have a counter value that's equal to 0. So while this stay in the loop is true, which it is right now because I said it at the beginning, it will go through and run this code right here over and over and over until this comes back false. So the exit condition for this will come from something inside of this here. So you want to be careful that you don't create an infinite loop, because if, say, for instance, I remove this and I just say x equals 1, if I run this, this will run forever until I break the cell. And if you have that happen, that's okay. It happens. You can press the stop button right here to interrupt the kernel. So if you press it, it stops this, right? So now, if we go back into this here, what it's going to do is if the counter is less than 10, it will print the number, right, that's in the counter, and then it will increase it by 1. If the counter is equal to 10, then it will no longer do this section. It will do the else. So this is what the else section is. Then what happens is it will set stay in the loop to be false, and it will print, hey, I'm exiting, right? Then once it's left this portion, it hits the while, and then it doesn't run again. It just goes to the end of the script. So if you hit Shift Enter, what happens is it prints out the counter. It happens in a flash, and then it exits the loop. To show this maybe a little bit more in depth, let me show you something here. Show you something that might make this a little bit easier to follow as to what happens. So what's going to happen is every time it runs through, it's going to wait for half a second. So if you see, this is what's happening right now in the loop. And then it's done. That's it. So conditional statements, you saw what was happening earlier. If you run this, it looks to see, hey, what's the first word in this if statement, or this word that I gave here? Is it H? So that's what this double equal sign is for. So it's looking at the first thing in the word, which is H, and it's checking, is it H? And then it prints out, yes, the first word of this is H. And that's what the output is. If I were to change this to a lowercase, case does matter, then it says there is no capital H at the beginning of this word. So that's an example of a decision that can happen within this. Functions. So this is a bit more of maybe a complex function here that I was going to explain. So say, for instance, I have a function called starts with H, like building upon this previous one here. Starts with H, and it does the same thing. It's this exact same thing. It's just within this definition here. I set this list, define it, and then I combine this with the for loop. And notice how this for loop looks really nice and pretty. So now it just goes through for every word within words. Does it start with H? And then it runs, and then it prints out, yes, this starts with an H. No, that does not. No, that does not. And yes, this one does. So does that kind of make sense so far with what we were at with like conditionals and loops? I will go into importing libraries and some of the other stuff after this here. So that'll be a lot of the built-in functions for Python. Okay. Well, if you have a question, drop it in the chat and I'll try to come around to it. So I think we've got about half an hour left, so I want to be able to answer any questions that y'all have or examples that you want to see. So import pandas as PD. So you were wanting to see how to import these libraries, right? So at the very beginning of this, we will import this. So you do import, and that shows up as green, all lowercase, and then the library name, in this case, it's called pandas, as PD. So you can skip this last portion of this if you do that, but that means that instead of calling PD, I have to say pandas.dataframe. And that's how I create a data frame for this here, right? But that's a lot of typing for that, and that might be a little cumbersome. So you can use the shorthand to call it something. generally it's accepted to use PD, but you could use it as something else. So like I could say pan, and then I could call pan dot data frame or whatever, but this is what's generally accepted for that. And the reason that I am suggesting using that, the reason I am suggesting using that is almost all the examples that you'll find online will use that PD, the shorthands that I'm giving here. So here's an example of what a data frame would look like. And when you give off the data frame output for this, gives you a nice pretty graph that you can look at here. Compared to the old list, you couldn't really tell what was what. So this is one of the benefits for pandas. There's a lot of other ones. So like an example of this is I could do, let's see here. Yeah, to CSV file.csv. I may have to look up the, yeah. So I saved this file here, right? And this is a file that's saved where the script is. And if I want to create a new file for that or read that into a new data frame, I can say data is equal to pandas PD read CSV, and it's an underscore, all lowercase, open parentheses, and then I give this exact same file name here. I think that should be the correct. Yeah, okay. Then if you call back data, it comes back like this here. So what's interesting is now you have an extra column here. So the reason for this is that this right here is the index column. Pandas did not know how to interpret that. So this is actually the index column here. There's a lot of ways to set that. That's something that you can like look on the pandas wiki to say like index true or unindex, remove index, whatever, or you can say what is the index. I'm not going to go into that because we have some a few other functions and I'm sure you'll have questions. So NumPy, same thing. Import NumPy as NP. And then if you are unsure how to import a library or what the name of it is, you can just look it up. So if you want to look up NumPy in this case, I mean, if I looked up NumPy, and I bring this up here, the documentation for this will show you how to get started for it. So you can see how to install it, how to import it right here. This is what I was talking about when I say that they have fantastic documentation on this and they tell you exactly what you need to do and how to do it. So in this case, just like they had typed, I'm importing it the same way and I'm giving it the same shorthand. And now, so for NumPy, you have this interesting way to create these arrays, and there's tons of ways that you can do this and manipulate this. Much easier than it would be doing this with Python's built-in functions. You'd have to use a lot of loops and if statements, and it gets very complex. So say, for instance, I want to create a list that goes from 0 to 14. I want 15 things in that list. I run that, and now I get an array, which is just a list from 0 to 14, right? But what if I want that to be a rectangular array? What if I want it to have 3 rows and 5 columns, but still 15 items in it? So if I add this extra portion to call it to reshape the array, so like if you think of it as one long array, right? You can shorten it and make it fatter, basically. So if you do this, if you notice now, it creates this kind of pretty like array that might be a little bit easier to follow. NumPy is also able to do element-wise operations. So like, if, for instance, if you wanted to do the sine or cosine of this, I think actually I have this in this one here. Oh, I guess I didn't save it. You can do like NP sine of A, and I think that will give you the sign. Yeah, so that gives you the sign of every number inside that array. And it's a very simple, easy function to use. You just get the sign for every number inside of that. If you wanted to do that built in, it's a lot more complex. You have to use a for loop and have an if statement and so on and so forth, and that gets very complex. So these libraries let you have these shorthand functions that save you a lot of time in programming. The reason I teach you some of those things is so that you understand what they're doing kind of behind the scenes or under the hood. So some extra functions that you may use that may be helpful. There's a sleep command. The sleep command puts the process in waits. So what happens here is that it literally halts the process for the number of time in seconds. Sometimes this is important. If you're grabbing data from a database and you are afraid that you're going to overload the database, you can slow down the requests by having the process wait. This is one way to do it. There's tons of other ways to do it, but this is probably the simplest way. And maybe say you send a request, you wait a couple of seconds, and then you send a request again. You can put that, for instance, inside a loop. So that's done doing import time. Time does all sorts of time management stuff. So this could be getting the date and time. It could also be the same as getting the program to wait, or measuring how long the program takes to run. Maybe you want to have a really fast analysis and you're trying to improve someone's method, right? And you want to time it. You would use that. Date time is another really interesting one that you can use. That gets you the exact current time and date, and all the way down to the milliseconds that your clock is running. So all the way from years, months, days, hours, minutes, seconds, and all the way down to, I think, picosecond or nanoseconds. I'm sorry. Yeah, nanoseconds. So very precise. You probably won't need that precision when you're using date time, but it is there. We've talked about string split. I kind of showed you all that a little bit earlier, but you already know how that works. But say, for instance, remember earlier I had mentioned, what if we had numbers and we want to use those as numbers? If I try to take the first thing in this, the 100, and I try to add 10 to it to see what I get an unsupported operation, meaning that I can't add 10 to a sentence. That just doesn't make sense. Like if you try to take a word and add a number to it, it doesn't work that way. However, if I use what's called the int command, integer, it forces that number to try and recognize what kind of number it is. So in this case, if I run int and then I add 10, I get 110. So it's 10, and then this becomes an actual a number that's 100. There are some other commands too, like operating system commands. So you do this through importing OS. This is a lot of stuff that you might see in trying to read file names, creating files, copying stuff. So if you remember, I mentioned earlier the operating system, like the way that people used to use computers, they entered in those commands to do basic math functions or create files, create folders. The OS lets you manipulate the computer's ability to do that. So a good example of this is, say you want to know what directory you're working in, right? So in this case, for instance, since I'm not working on my home computer, we're working on my GeoHub, this is the folder that we're working in. So that's what the current working directory is. So get CWD is get current working directory. That's really important for if you have like a script that you need to know where files are and you need it to read stuff. You can take that current working directory and you can add things to it. So that is about it. If you have questions, feel free to send them now. If you have examples that you would like to see, I'm happy to show a few of them. And then I think at about noon, I think we'll go to lunch here. So I think we've got about 15 minutes if you all want to see me try and set something up. Hopefully y'all are feeling capable now of being able to create a simple program. Yeah, so importing a file. So say for instance, maybe you want to import a CSV file, right? So let's do this. I will start this blank and I will create a new Jupyter file, and I'll do this from scratch to show you how you would do this. So say you, give me 1 second here. So say you want to create something and you want to import a CSV file. So we have, let's see where I have some data. So let's see. Yeah, I've got some data here. So, okay. So say I create a new Python 3 script. So remember I mentioned inside of this, you can create your own scripts. I create this and it sends me to the editor for that script. I can rename this. I'm going to call this the intro example, maybe 5 or something, because I think I had 4 before. The first thing I will do is import pandas as PD, right? So I import that, I run it, and boom, it's done. That's how you know it's done, is it has a number next to it. The next thing that I will want to do is I want to create a blank data frame. So df is equal to pd dot data frame, and then that's it. It's blank. You know, you don't have to do this section, but I like doing that because I feel like I understand what's going on in the code. And then you can say df is equal to pd dot read CSV. And then you give the file name. So here's the thing with file names and file structures. If you are working in the same directory that your file is, right? So in this case, I have this file right here. This is the Python notebook I'm working in. And I have all these CSV files that I want to import, right? Tons of CSV files here that I can import. So let's import data test. So this is for the machine learning example, but we'll use this as an example. So data, oops, is it data test dot CSV. And that imported the file into the data frame. So now if I just press data frame and I just try to call it back to see what I get all of these sets of data for this. It's got 16,000 something rows and 27 columns worth of information about, in this case, building energy. So this would be, I believe this example is for energy usage and I think maybe kilowatts. So for instance, if you wanted to do something with this data, a very brief example would be calling a function within the data frame. So df.plot will give you a very dirty plot of everything, but that will probably take a really long time to run that. Oh, I guess it didn't for this one. So that gives you a really crazy plot, but because there's 27 columns, it's very dense, right? So remember earlier I mentioned the key pairs. So maybe let's just look at the first one here. So the first one's got this name right here, right? So let's do df e. So let's open up the heart brackets. This right here, right? And then let's do dot plot. And then that gives you just the data for this here. So you can get some really interesting data just real quickly looking at it, faster than you would normally in Excel. These plot functions are built into Pandas, but they use another library called matplotlib, or Python plot or pyplot for short. That's another lecture that we'll be talking about that. And so earlier in this same realm, you use that exact a different but very similar command to save that data as a CSV file. You can also read those as Excel files. I believe it just says read Excel if you want to say that instead. I don't have any Excel files saved up here. Those have more inputs because Excel files can have pages. I typically recommend just sticking with CSVs for now, just for the simplicity of it. Does that give you a good overview of how to import a file? Cool. Yeah, and there's tons of other things that you can do. So I'm trying to think of examples of this. You could you import us current working directory. So if, say, for instance, maybe you have multiple files that you want to import, right? No. Well, okay. The question, yes, it does look a little different. So I can tell you what the differences are, and I can show you really quick, actually. My GeoHub has this button right here that takes you to their homepage. The other option too that comes up that's not normally on your home PC is this terminate session button. If you are working in, so let me terminate this real quick and I'll show you what it looks like normally on a home PC. So you can launch this through what's called Anaconda, which is a manager for this. You can also install this manually. So normally when I launch this, you create this through a not PowerShell, command prompt or PowerShell. And what you do is you launch Jupyter Notebook. You have to install all of this stuff on your home PC, and you'd have to look up how to do that. It's pretty easy, but you launch this, it creates Jupyter, and it brings you to this here. So great example of what's different. You don't have the My GeoHub on the left, and you have two buttons now on the left, quit and log out. If I open up a file, so this is one of the exact same scripts that we were working with, you have a log out button. It's just a little bit different, but for the most part, you probably won't notice the difference. So that's about it though. Not that many big differences on it, so. Yep. Any questions? We have about 8 minutes. I can try to maybe hammer out one more example if someone wants to see something. Something somewhat simple. And if you want to play around with this, by the way, so I guess I can tell you this here. So you can launch it through the course, but if you're on My GeoHub and you want to just play around with it outside of the course, you have access to Jupyter on that. So you can go to Resources, Tools, this right here, and click on that. And then you have access to all these tools here. And you'll learn some of the other ones in the other lectures, I think. But for Jupyter, though, look in the resources here, and you'll find one that's called Jupyter Notebook. And you have one with the Anaconda and one without. Just run the one that just says Jupyter Notebook, and you can launch this tool, and it launches it outside of the context of the class. So if you want to play around with the scripts and all that, you can. Quick word of like note on this. My GeoHub is very unique in that it has a lot of those libraries already installed. Normally, if you wanted to install libraries on your own, you would have to go open a terminal, and then you would have to run an install function for something. In a lot of cases, the first thing you might install is pandas. Thankfully, all the stuff's free, so you can have access to this at home if you want to use it. So, but I believe that is it. So we have about 5 minutes left. I think I used up almost the exact amount of time. I hope I didn't overwhelm you guys too much. I know it's a lot to learn. Programming takes a lot of practice to really kind of get the gist of it. Sometimes it helps to talk through things with someone, or to write down your ideas and like a flow chart to see what you want to do. Best tips I could give is don't be afraid to look something up. Don't be stubborn about it. Someone else has probably done it, so. Yeah, so for practice, I would probably go to, let's see, the Python resources. This guide right here, I would pick one of the tools that you want to do. Probably what I would look at is inside of this interactive tools and lessons here. I would probably look at that. You can also go, one of these is for Jupyter. Oh no, I guess they don't have one on here for that. This just goes through like the basic programming task. Would you recommend programming tasks for beginner to start learning how to code? Yeah, so beginner tasks so let me tell you what my tasks were that I started with. So my basic beginner tasks started off with, I was actually doing text mining for civil engineering. And this is where I learned a lot of the stuff that I was doing. Working with an application programming interface is a very good way to start. Yeah, you can find tons of those. I can give you, I think Pandas Cookbook's probably the best one that I can think of. This will give you a good introduction on data science and pandas. I'll leave that one in here for you. They have some good examples on like how to use pandas because you will probably be using that a lot. Jupyter, you might want to go through and do some like Jupyter tutorial. I've shown what I can, but you may want to go through and look at like Bootcamp would probably be a good place. But find the free resources. There's always going to be a free resource for it. I have personally used the Codedex. That one's a really good one. This one's kind of a very basic. Oh no, is it no longer up? Oh. Oh, there it is. This right here. And it kind of does it in like a video game environment. I always thought it was kind of fun. That's another one that's a good one. It just gives you the very basics for it. Really, my recommendation is if you have a project that you're trying to do, a good task is to try and automate something. So say you have a task that you manually do. Maybe it's renaming files. Maybe it's analyzing data, calculating z-scores for statistics, something like that. Try to automate that using Python, using the for loops that I mentioned, the if statements. That's always a good place to start with that. Usually it's a simple enough task that you should be able to do it within like maybe a few days to a week, depending on how much time you have to work on it. And it feels very rewarding to know, wow, I can just shift enter, run, and boom, I no longer have to work for an extra hour to do this by hand. So find something that you think you can automate. I think that's what I would say, and that's what I would recommend. I think that's about it. There's tons of user-created libraries too. machine learning, stuff like that. There's really a lot that I could go over. I could spend a whole semester talking about this. So, Zen of Python, I think, was a good one too. I mentioned that book earlier. I think it might be a little bit in depth. I think that's if you want to kind of look at that. This talks about just the basic things that you should kind of remember. It's not really examples and stuff like that, but it's a good thing to check. So some of these were things that I had brought up. So okay. I think it's about lunchtime. I don't want to keep y'all any longer. If you have specific messages, you can send me a message. Otherwise, I will let you guys go.